In this video, learn how to create custom Scikit-learn transformers for tailored data preprocessing. Master the skills to design and implement your own transformers effectively.
Welcome to our guide on building custom Scikit-learn transformers. Did you know that properly tailored transformers can drastically improve your machine learning model's performance? Today, we'll explore how customizing your transformers can provide the flexibility needed for more nuanced data preprocessing, which is essential in crafting effective machine learning pipelines. By the end of this video, you'll be equipped to design and implement your own transformers, enabling you to handle diverse datasets with ease. Let's dive in. Let's start with a fundamental overview of Scikit-learn transformers. These components are pivotal in machine learning pipelines, serving as the tools that prepare your data for modeling. Unlike estimators, which predict outcomes, transformers focus on transforming data. They're equipped with two essential methods: fit, which learns from your data, and transform, which applies learned transformations. Common transformers include standard scalar and one-hot encoder, each playing critical roles in preprocessing. Understanding these basic components sets the stage for building custom solutions that address specific data challenges. Custom transformers offer significant advantages, especially when dealing with unique data challenges. They allow for the implementation of custom logic, enabling you to address specific nuances of your dataset effectively. This customization not only improves data transformation but also enhances the reusability of your transformers across different projects. By integrating seamlessly into pipelines, they ensure consistent and efficient preprocessing steps, tailor-made to handle domain-specific needs. In the long run, custom transformers can vastly improve your model's adaptability and accuracy.
Before we dive into coding, it's crucial to set up your Python environment correctly. Start by installing Scikit-learn and other necessary packages using pip. Setting up a virtual environment is recommended to manage dependencies and ensure compatibility across projects. This practice not only isolates project requirements but also prevents conflicts between package versions. Remember to check for the latest updates and troubleshoot common setup issues to maintain a smooth workflow. Proper environment management is foundational to any successful machine learning project. The fit method is where your custom transformer learns from the data. It's designed to compute and store any necessary statistics that your transformer will use later during the transform phase. For instance, if you're creating a transformer to normalize data, the fit method would calculate the mean and standard deviation. It's essential to tailor this method to handle different data types effectively. Implementing best practices in this stage ensures that your transformer is reliable and performs well under various conditions.
Once the fit method has recorded the necessary statistics, the transform method applies these transformations to the data. This method ensures that your data is transformed consistently according to the logic defined in fit. Whether you're scaling, encoding, or imputing, maintaining data integrity is paramount. By following best practices and ensuring that transformations are robust, you can reliably process new data. This stage is where the magic happens, turning raw data into model-ready input. Incorporating custom logic within your transformers allows you to integrate domain-specific knowledge directly into your data preprocessing steps. This could involve conditional transformations based on specific criteria or incorporating error handling to manage unexpected data inputs. Customizable parameters make your transformers versatile, allowing for easy adjustments as project requirements evolve. Testing and debugging are crucial at this stage to ensure that your custom logic works as intended and produces reliable results. Testing your custom transformers is a critical step to ensure they perform as expected. Begin by creating test datasets that simulate real-world scenarios. This allows you to verify the transformation outputs and ensure they align with your expectations. Utilize Scikit-learn's testing tools to streamline this process and identify any issues quickly. Based on test results, iterate on your design to refine and improve your transformer's accuracy and performance. Testing not only validates your transformer but also builds confidence in its robustness and reliability. Integrating custom transformers into your machine learning pipelines is the final step in ensuring their utility. Pipelines allow you to apply multiple transformations in a sequence, streamlining the preprocessing phase. Ensure seamless integration by managing dependencies and verifying compatibility between different pipeline components. By optimizing your pipeline's performance, you can achieve faster processing times and more accurate model outcomes. This step solidifies your custom transformer's role within a larger machine learning workflow, enhancing overall efficiency and effectiveness.
Adhering to best practices in custom transformer development is essential for creating effective and maintainable code. Follow Scikit-learn's guidelines to ensure compatibility and leverage community support. Maintain code readability by using clear naming conventions and modular designs. Document your custom logic thoroughly to facilitate collaboration and future updates. Implement version control practices to track changes and manage different iterations of your transformers. Finally, stay updated with machine learning trends to continually refine and enhance your approach. While developing custom transformers, there are common pitfalls that can derail your efforts. One major issue is neglecting data validation, which can lead to incorrect transformations. Avoid overcomplicating logic, as this makes debugging and maintenance challenging. A lack of thorough testing can result in unreliable performance, so always test your transformers extensively. Performance optimization is crucial to ensure efficiency, particularly when processing large datasets. Finally, never overlook the importance of documentation, as it aids in collaboration and future development efforts. By being mindful of these pitfalls, you can create robust and reliable custom transformers. Congratulations on reaching the end of this comprehensive guide on building custom Scikit-learn transformers. We've covered the numerous benefits these transformers offer, from enhancing data preprocessing to improving model performance. Now, it's your turn to experiment and implement what you've learned. We encourage you to leave comments with any questions or insights, and don't forget to share this video with others who might find it helpful. Stay tuned for our next video, where we'll dive into advanced pipeline optimization techniques. Thanks for watching.